Orit and I wondered when we began our book project about 6 or 7 years ago, what exactly is smartness in terms of smart technologies, and how and why has it come to seem that everything, or that smartness must be implemented everywhere? We try to illuminate the deep logic of smartness and its mandate in our book in 4 chapters. Each chapter takes up one of the following questions. First, what is the agent of smartness? That is, what precisely enacts or possesses smartness? Second, where does smartness happen? That is, what kind of space, or maybe even better, territory does smartness require? Third, what are the key operations of smartness? That is, what precisely does smartness do? And fourth, what is the purported result of smartness? That is, at what does smartness aim? And our answers to these 4 questions are, very briefly, as follows. We argue that I guess we'd call them the quasi-agents, they're not quite agents in the traditional sense, of smartness are populations. Smartness's populations include human populations, but only insofar as aspects of human populations can be rendered into digital populations. And one result is that one human individual is part of many different digital populations. Smartness also employs many digital populations that have only the slimmest of links to humans. Second, the territory of smartness is what we call the experimental zone. Since the populations that smartness employs often do not map onto the national borders, into which human populations are politically divided, the architects of smartness frequently employ a logic of exception that characterizes the territorial concept of the zone. And we're thinking here of something like free trade zones, which have a logic of exception, to create hybrid digital material territories that can be structured to generate new forms of experimental computer-assisted learning. In the 3rd chapter, we argue that the key operation of smartness is derivation. And we use this term with the financial sense of derivative in mind, a derivative. And we're using that to stress that smart systems generally piggyback on and splice together existing systems and activities, and so are in this sense derivative of something already there. In addition, and also in connection with financial derivatives, smart systems are technologies of temporal management that are able to exploit current computational limits as both a present source of value and a hedge against a future that is understood as always unknowable and threatening. And finally, and 4th, smartness aims to produce resilience. The logic of resilience, which in the sense that we use it in the book has its origins in ecology, names the capacity of maintaining identity despite constant shock and change. As we know, the logic of resilience, and hence of smartness, is future-oriented, but it aims not at a future that will be better in any relative or any absolute sense. Instead, the future is understood as simply a source of ever new and always changing shocks. In this sense, smartness is, we argue, fundamentally anti-utopian. Those are the 4 parts of the book. Each chapter is essentially a historical genealogy of that particular element of the smartness mandate. It probably is worth saying that our book is likely one among many possible genealogies of smartness. And this isn't so because the difficulty of writing any genealogy of smartness is that smartness brings together so many separate histories of computer hardware and software, computer modeling, governance techniques, logistics, economic theory, and financial tools, to name just a few of the histories that we discuss in our book. And so a key challenge for us in writing the book was to figure out by means of what historical arc, or maybe even better, historical rhythm, we wanted to implot our account. It was, of course, tempting to focus on just the most recent developments in computing hardware and software in the most recent ways in which those have been tied to projects of, say, logistics and governance. But we felt that that kind of essentially presentist story missed the extent to which smart technologies and smartness itself as a concept and aspiration is in fact an assemblage of wildly heterogeneous technologies, techniques, and discourses developed over at least the last 70 years. And so our solution to the problem of how to narrate our story was to structure each of our chapters according to a similar 3-part temporal rhythm. Thus, in each chapter, we focus on, first, a set of technical and theoretical tools developed in the cybernetic sciences around World War II. We then show how these tools and techniques were reframed in the 1970s in accordance with specific forms of global political turmoil, as well as an increase in computational capacities. And then in the third moment of each chapter, we look at how these assemblages began to take on their contemporary form in the 1990s and early 2000s, which was both a period of extraordinary increase in computational capacity and global networking, but also a period of consolidation of neoliberal governance methods around the globe. And so to give you a brief example of what that historical rhythm looks like, in our discussion of the development of computer hardware and software that is structured to learn, which is the basis for current learning algorithms and artificial intelligence, we begin in our account with psychologist and computer developer Frank Rosenblatt, who developed the perceptron model of learning in the 1950s, which was intended to perform basic character recognition. Rosenblatt explicitly connected his attempts to enable computers to learn to a wave of late 19th and early 20th century psychological research on animal and human learning, that is, to researchers such as Ebbinghaus, Pavlov, Skinner, and so on. Rosenblatt perceptively suggested that these earlier experimental approaches to learning each focused on different kinds of learning, and hence the arguments between these researchers about what constituted learning. Rosenblatt, guided by the sense in the 1950s of computers as all-purpose or potentially all-purpose devices, wanted to develop a mechanism that, like the infant human mind, was not oriented towards one specific kind of learning, but could be taught to learn many things. And Rosenblatt's research still serves, though now somewhat distantly, as the bedrock of many contemporary machine learning algorithms, which can now be oriented towards many different learning tasks. So the first part of our history of computer learning focuses on the technical development of computer learning. But there's another history of computer-mediated learning that emerged in the late 1960s and 1970s that was focused on the desire to integrate whole populations of humans into computer-mediated learning. And in our book, Orit and I engage the second moment of our story, or that part of the story, through the figure of Nicholas Negroponte and his project of soft architecture in the 1970s. We suggest that this approach stands behind our contemporary goal of so-called environmental computing. That is the goal of ensuring that the built and non-built environments through which we move are filled with sensors or accessible to sensors, so that the details of our individual lives can become the source for computer-mediated learning. It's tempting to link this, or Negroponte's project, to the individualized surveillance tradition of the panopticon that Michel Foucault described so well, but there really was a different aspiration here. For Negroponte, the point of environmental computation was not to track people to ensure that individuals conform to a given norm. Rather, Negroponte saw each individual as a source of novelty and originality, and felt that computers could be used to pool these individual perspectives and so enable a mode of collective learning that could not otherwise occur. And so the point for Negroponte of having sensors everywhere was to access and preserve as much individual originality as possible, not to ensure compliance with norms. Negroponte felt that this approach would allow urban planners to resolve many of the urban and global tensions that marked the 1960s and 70s, including so-called urban decline and urban racial tensions. And then in the third moment of that chapter, we're interested in how these two very different approaches to computers and learning, the first originating in the 1950s with people like Rosenblatt, the second in the 1970s with people like Negroponte, were melded together in the 1990s and early 2000s via technologies such as the Google search engine to create something like population-based computer learning as we now understand it. So I hope that gives you a sense, albeit without many of the details, of how the book and its chapters are structured. And I'll leave it at that. And then if Orit has any final words to add, we can, yeah.
Yeah, I just want to say, because I was showing the slides, so I'm hoping that people kind of got it since I wasn't sure what people were seeing. But our point is, as you noticed, you may have been seeing kind of images both of these large-scale infrastructural developments as well as urban-scale experiments on people of color or minority populations. And a critical question around smartness, of course, is how it's reconfiguring notions of quote unquote the human population. In terms of population, what are the political and ethical implications, of course, of this, and how we can demarcate these contemporary histories to older histories, right, of race, economy, demography, and Malthusianism, as well as biology and evolution. And I want to say that a critical feature of this is also thinking very much about the relationship between the environmental and the computational. So one of the central features of the smartness is that it bridges scales from individuals to kind of planetary scale sensory infrastructures, but particularly that it introduces these questions of evolution and biology into computation. And so a big central project for us is not just asking about democracy, but asking about things like biological determinism and what constitutes things like evolution, learning, adaptation. Or these are the questions we want us to ask, because we think there are ways for us to rethink things like artificial intelligence away from merely the kind of limited imaginary of metrics and the quantification and rationalization of intelligence that we know well from the histories of IQ and race, to actually broader questions of what constitutes learning, and recognizing that these sort of questions are also political, social, ethical, and aesthetic kind of controversies or debates.
Perfect. Thank you so much, Orit. Yes, this is a remarkable book. I mean, it's a denser book. I will confess. But it's well worth a read, precisely because it's so good at bringing these different strands of thought together, maybe computer science, psychology, evolutionary theory, and it's very, very good. I mean, also I'm thinking about your past works for both of you to relocate what we tend to think as something that is intrinsic, innate, determined in a certain way within its highly contingent history, and to historicize what we tend to think as basically very, very much is essentialized. I mean, you even go back to, to the Malthusian conception of population, managing populations. You pass through histories of neoliberal thinking from Friedrich Hayek to Ernst Mayr's evolutionary biological account of speciation, Nicholas Negroponte, as you mentioned, the demo or die business model. And you haven't so much spoken about this in your presentation here. So maybe before we delve into the juicier parts of this discussion, maybe you want to elaborate slightly on this idea of the demo or die business model and the idea of the Black Skulls model of noise in markets. And perhaps also the impact of the Club of Rome's Limit to Growth landmark report, how it seems to have had a substantial impact on various strands of thinking.
Well, those are a variety of different things pulled from different chapters. If there's a broad kind of notion, perhaps underpinning all those examples, it's how large scale, like planetary scale computation manages risk and futurity through different techniques. So what links the demo or die model with the derivative, with the actual testbed urbanism, with like full scale cities that are built as kind of experimental sites for new technologies in some sense. If we think of these greenfield cities in East Asia, where I started working on this, we're looking at large scale ways that people are hedging bets and taking large scale risks, often on things like burning carbon or, other rather dangerous and large scale kind of economic, political, and social risks with life, and how they're managing it through different modes of deferring or managing futures. So the demo is always like, it's a strategy around responsibility. So who's responsible if it's just an experiment? And this is actually not just a conceptual problem. This is actually a real thing. Like, the NHS has just had its full data bought by Palantir because supposedly they were just testing COVID apps during the COVID pandemic, and they inserted themselves and now are basically taking over the entire data of your national healthcare system. Yay. I say that pretty sarcastic, but that demonstrates actually the way something that says it starts as an experiment, kind of subverts the standard legal, legislative, procedural methods of democracy or politics that would otherwise decide whether or not to take a contractor, takes over a large-scale system such as the National Healthcare Service's entire data and analytics, along with security concerns.
Okay. Yeah. We'll
So,
delve into that into a few minutes. But I had a question, because basically when one reads your book and when one thinks about, especially looking back and thinking in terms of genealogy, one cannot but be reminded of all, these previous 19th century, 18th century, especially 19th century projects for, these technocratic cities, and my kind of question is here, how do today's dream of a smart city, how is it different from those projects? I mean, in a way, could we not argue that these smart cities within a smart planet are ideal? I mean, they manage everything rationally, they optimize everything, obeyed with sensors, which are embedded everywhere and embedded in more traditional structures. They employ high-end computing and learning algorithms to analyze data and plan and to recycle perfectly. And, so in a way, how perhaps, they do remind us of these utopian cities. And you've made a point to say precisely that they are not like these utopian cities. So how would you say that these new rationalized, optimized cities, how different are they from past fantasies, past dreams? And what kind of societies and cities are we developing towards what aims? And what is the goal of this city, of this new city, aside perhaps from adjusting to any new and unexpected threats and possibilities and constantly learning perpetually?
well, I don't know, Rob, if you want to say, well, just a real quick basic answer is actually, it's exactly utopia that's been kind of lost. There is no final form. There's always a version, there's always an expansion, there's another place it goes. Its even form is urban. I mean, currently, whether in urban studies or just logistics, we kind of have these new notions of hinterlands, new ideas of urbanism's relationship to rural. Like there's no end to the network, and it's a very different formation. There's also this question of constant learning. Maybe Rob, you want to talk about that?
Yeah, no, we really do want to stress the non-utopian nature of smartness and smart cities. And there's two ways of thinking about this. I think for the architects of smartness would try to say, well, look at the hubris involved in earlier attempts at utopia, because these people seem to think that they knew, and these were often, say, white men, seem to think they knew exactly what everybody would like, and so they could design an urban form that would then fulfill that. And so what we do, we first of all have a method that allows much more, many more people to participate. But the downside of that is that there's no end to that process. And the future is no longer understood as the time in which aspirations will be achieved, but it's rather understood as simply the temporal point from which storms and crises and shocks will always emanate. And so smartness is a non-utopian in the sense that it's more like a constant defensive gesture against the unknown threats that the future will bring. Again, it's, we're critical of many aspects of smartness, but we also try to take the core of, we try to understand it too, because the point is like, we can't know the future. That's true. But I think a little disturbed, or I think we're both a little disturbed by, is the lack of even aspiration. It's an attempt to say because we can't know the future, really the best we can do is just constantly learn. True, but it's a little bit underwhelming when set against the aspirations of earlier urban planners.
Yes,
There's
thank
also a
you.
whole question about democracy. Yeah. I mean, like, can you have participation without democracy, which is an argument that's been leveraged against things like, City Brain by Alibaba, that, people can complain about their trash and get immediate urban, responsiveness, but there's also the surveillance autocratic system around it. And the same could be true in corporate or other settings. I don't want to just single out China's, but it's exemplary in a certain way of a certain logic of participation without power.
Yeah, so that the idea is that the smart city will it's always learning from even the most minor of voices in the smart city space, but because it's all mediated through computer-based learning algorithms, there's never any point where those voices come together. And that seems to be sometimes part of the point, is to certainly take into account all of these separate voices, but to keep them separate as well. Or that's at least, and if that's not the goal, that's at least intrinsic in the mechanism. And that's, we end the book with a, what I wouldn't call it, it's attempting to be hopeful conclusion about democracy and smartness, but it's certainly a concern for us. Like where does a collective voice go in all this, and not simply, yeah. So that's a concern that's connected with what we see as the anti-utopian nature of this.
And how you harness the potential, for the good, the potential in precisely that distributed, individual, distributed intelligence and individual voices. Something that really strikes me, I mean, and I'm very interested in epistemology and rationality, and it's a topic really that haunts me. And so I'd like if we could perhaps move to looking at examining, smartness in this context, in this history of reason and rationality. You illustrate very well how we've shifted, from Cold War rationality, which, was pretty much about control, vying for stability in a finite and closed system, a self-stabilizing homeostatic system, which was top-down. And now how with smartness, displays constant innovation, perpetual movement, distribution, and very much, it's a self-regulated process and very much operates on simulations, speculations, derivations. And, we used to be in the period of IBM's Think, and now we've moved since the late 2000s to Smart with all these things. So if we could probe perhaps slightly more how smartness compares to rationality, compares to thinking, and how we've shifted from that, finite more rationality to this networked smart rationality, from optimization, or rather even more refined, from optimization to resilience, speculation, and derivation. And what really is derivation? Because there are two words really that are really very present in your work, and which makes your work unique, because there are many books written on AI, right? But you probe, you tell us, you examine that logic, that new logic of derivation, derivation for resilience. What kind of, first of all, how is resilience different to adaptation? And what kind of world do we have? And what is the novelty of this new approach? Thank you.
Again, that was a lot of question. So within the history of, let's partition it. There's the history of reason and kind of human decision-making and agency. And within that, I think that we obviously signal this as sort of going even beyond the rationality of like game theory and expert analysis of like the Cold War, in the sense of the democratization of these techniques, in the sense of like there are no more experts, everyone's everyone can hack and kind of play with it and kind of build. We're all DIY. So you see something happening there. It is beyond, and it's not just that it's self-organizing. And actually regulation, I think, is kind of under erasure. It's not that nothing's regulated. It obviously still very much is. It's just that there's a kind of effort, I guess, somehow to evade that. Then I don't know, Rob, do you want to take, I can take, I guess, a little resilience, and if you want to talk about derivation. Yeah.
Okay, yeah, sure, yeah.
And maybe give us a concrete example of what derivation is, because I feel it's maybe a bit abstract, concrete.
Well, I mean, so again, we're interested in two things in the derivation or derivatives chapter. One is just the ways in which smart projects are funded, and we don't go into great detail on that topic, but we're interested in the extent to which these are speculative projects that often rely on having very little capital in the game, but then projecting a grand future and gaining investment on that basis. So there's that part of the derivatives, but we're more interested in the extent to which smartness is an attempt to harness something that's there already, but is not yet coherently connected into a system. And so that example that we have from Negroponte, where you've got a city, there's people doing their activities, and Negroponte. So there's already existing systems that are social systems that are occurring in the city. And Negroponte's idea was like, if we just could have more sensors, we could then make some of those activities cohere into a system and provide feedback to people. So it's this system, this computer system, would be derivative of it's based on, requires the pre-existence of another system that's out there. And that, we're saying, is one of the key operations of smartness, where it's taking something that's implicitly a system or could be a system, and then making it into one and creating both the capacity for learning and also the value out of that. And so in that sense, like a derivative, a financial derivative is derivative of something else. It's not the company stock, it's derivative of the company stock. So we're using that sense of derivative to try to get at what smartness is doing. And the idea is, with say Negroponte, but many smart city examples as well, is that there's all this implicit smartness there, but it's just not there's just no way to channel it unless we can get a lot of sensors and computational systems in place. Then we can turn it into a learning system. So it's the piggybacking of a computer assisted system on the basis of something that's already there. Now, in the present, it may be piggybacking a computer assisted system onto another computer assisted system, but that's the notion of derivative that we're using.
How very clever.
Well, I also want to really accentuate the fact that we're really one of the things that gets kicked out of AI, except is in the term of capital, in a very vague, like capitalism's out there in AI and platform capitalism, but people actually kind of drop the specifics of finance. And the fact is, financialization is key to AI. We obviously haven't tracked the latest upswings, but I think there's also a clear mirror there between economy and how we produce value in the production of particular types of technology that I think we wanted to highlight. I also think we were really interested in the economy ecology relationship. So one of the things that's about resilience and derivation, and why we are so insistent on having them together, and we don't, rather than optimization, is that we're really concerned with how we naturalize certain technologies, certain solutions to social questions, certain economies as seemingly inevitable, deterministic, like we all have to adopt AI, extreme hysteria, etc. These things are never actually just automatic or necessary. They're socially constructed, contested, and contingent, and they obviously have power relations involved. So just to note there that there's an economy ecology relationship that we really want to think about, both in terms of biodeterminism and in terms of the way we're envisioning environment right now in the midst of the Anthropocene and the climate crisis in relationship to computing, which we think is at the core of smartness. Like in many ways, this is not about individual human computer interface interactions. This is actually population grounded and scalar. Smartness is always about infrastructure, and maybe AI is too. We could talk about that and what's at stake in those different languages. So resilience is a worldview that argues that volatility is the norm, and that natural systems do not return to past states, and that you can never stabilize them within the histories of ecology, that you can't manage for stability. You have to manage for change.
Thank you.
But of course, so that's a kind of basic thing, but it underpins the same way that things like derivative markets manage for volatility and uncertainty in financial systems, and the two mirror each other.
Thank you. I mean, going from that, I mean, you mentioned languages and you mentioned, what you guys have come to call the Smartness mandate. And I was wondering precisely to what extent, the role of framings and narratives that also runs through your book, the idea that certain things are naturalized. You mentioned the word naturalized, and how in a way crisis and disaster is naturalized as the norm, as the perpetual, as the way we live now, and how maybe crisis, what is the relationship between smartness and crisis, and what kind of maybe slightly paradoxical, relationship exists, if you could develop that?
I mean, I don't know if this directly answers the question. I definitely want Orit to answer this one too, but I think that this continues the point that Orit was making just a second ago, that it may be useful, we don't talk about this in the book, but it may be useful to think about this distinction, at least it's a distinction in American English, between book smarts and street smarts. And book smarts is probably what we would call rationality, where it's this knowledge that someone that can be gained from books and from logical thinking. And the idea of street smarts is that those book smarts will not get you very far once you're out on the street. And the street is a place of threat and danger. And so street smarts is the kind of smartness that you have when you're able to deal with an unpredictable urban environment. And I think the idea of smartness in terms of its relationship to thinking and rationality is precisely that it's able constantly to adapt to a changing and threatening context. And so it is a little bit paradoxical to say that crisis becomes the norm, because I mean, if it's always crisis, then how can you tell? But nevertheless, I think that if there's a very sort of natural evolution, red in tooth and claw kind of vision here, that that basically the reality is threatening. So in that sense, there's always crises, or at least challenges, or at least there's no guarantee of existence, and hence smartness becomes that ability to adapt constantly, and in an embodied way and in a non-book way to a threatening reality. So I think that it's, we say that crisis becomes the norm, and we do this in a sort of rhetorical way, but the idea is that there are constant threats. I mean, it's sort of in a Darwinian sense, and that is what smartness is able to deal with. And something like global warming, which clearly is, really is a threat, and one that's not going away for a long time, becomes a powerful, powerful means for smartness to prove itself, or to try to prove itself, or at least to claim that it will help us with this, because this is a real threat. And so the question is a real crisis. And so smartness claims, yes, or the advocates of smartness say this is the kind of approach one needs to be able to deal with something like that.
And then they tell us that we need more smartness, to deal with
in
the new crisis and so on. I like
it hasn't worked yet, then that's because we haven't had enough smartness.
So
Exactly.
just a thing, there's a lot of questions in the chat. I don't know if we want to respond.
We're getting there. I just wanted to ask
okay.
that final question. Rob mentions irony, and actually I find that in a way this is my main impression reading this book. The irony and the paradox is the fact that we have to terraform the planet to be able to create smart green structures, and that, but isn't there, I don't know, a smartness all around us, as you mentioned Susan Simard's, forests, the smartness of forests, and how is it, to what extent does the smartness of cities compare to the smartness of forests, and can a smart planet only exist in the digital realm? What about the smartness of the natural world? Because you hint towards that in your book towards the end.
I think one of the curious things about this history is that it's really critical to remember that when people came up with things like neural nets, they did not separate between the smartness of the neuron and the smartness of the machine. The question actually was more, we don't know what a brain is and we don't know what a machine is. We're going to try to build little tools or little machines that help us understand what both of those things could be. So I think that the general issue is that smartness is an expansionary topic that definitely allows us to begin consuming or perhaps reimagining many things as capable of sentience and intelligence, that it's not just machines. It really is back to the, I mean, this is, Donna Haraway first put this out in the Cyborg. It's not just machines, it's an epistemology. It's a way of understanding the world where everything is endowed with this capacity to learn and self-organize. So slime molds and fungi and octopi. And so there are many, many things possessing sentience within this new framework and this new definition, which stays away from questions of reason. And that's both the possibility of it, that so many new things are endowed with this capacity to make decisions, to be intelligent, to be smart. And at the same time, we absolutely have left aside or pushed aside questions of consciousness and, of course, agency. Because yes, all material matters, we can go all literal on the, have agency of some sort. But when it comes to politics, we're talking about the express, like we're talking about power and who has access to it, who can enact it, who can, consciously produce systems, produce representations, create meaning, structure a world. And so we are eliminating a whole series of questions or possibilities that obviously have troubled histories in liberal and enlightened thinking. And also ideas of agency that are obviously also linked to democracy and politics.
It would be
I don't know, Rob, you probably know.
There would be much more to discuss, but let's move on maybe to audience questions at this point, and I think Anthony will help us out here.
I will indeed. Okay, let's get cracking. So there's quite a few that have come through, and it's normally only once we start with the questions that the others tend to come through. So we'll start with Su Ming Ku, who asks or says, I'm fascinated more with changing understandings of who or what learning or smartness is for emphasized. It strikes me that there has been a sort of reversal from machines learning about people to people's main task becoming data producers to teach machines. This is not quite the evolutionary arc one might have expected. Rob, do you want to comment on Su Ming's statement?
Yeah, I mean, yes, a well put point. And I think that, the advocates of smartness would say, well, okay, but there's not a trajectory here. It's basically always a loop, so that the machines are learning about humans, so that then so that parameters can be adjusted so that humans can do something better. So that it's imagined as this learning loop that happens partially between humans and machines, but also between both and environments. And the idea is that the environment is constantly changing. Environment could mean like, the natural environment, or it can mean the urban environment, anything that's sort of outside the system. And that as that continues to change, and it will of its nature always change, then machines and humans together, I think the idea is more of a symbiosis, will be able to perpetually adapt. Will be resilient, and will be able to adapt to those changes. And the strong claim, I guess, of some architects of smartness is that a world of 8 billion people will only be able to do it through this way, right? So that though maybe forests, for example, have been smart forever, and humans may have been smart in different ways, as Shannon Mattern has suggested, in urban environments, that now at a certain threshold, you can only enable what was previously done naturally through a computer mediated network of humans and machines. And so, we're not convinced by that, but I actually did want to also say that part of the point of the book too is it is a critical book of smartness, but it is because we've used smartness in its mandate as an assemblage of very heterogeneous things that have been brought together, we seek to excavate some of, I guess I would call it, the more utopian potentials in some of those past moments, so that it's not a solely, critical book either. We're trying to say that, look, this is the current assemblage that goes under the name of smartness, but there could be a contest over this term and the technologies and the aspirations for it.
Thanks, Rob. Orit, do you want to pick up on Suming's original question or Rob's response?
About how people are becoming more machine-like or learning about machines. I mean, I think that there's a hint of truth to that, in the sense of we've obviously transformed both how we're defining, intelligence more broadly in a way that's made humans and machines commensurate and able to work together. And this has demanded, obviously, transforming the metrics by which we understand intellect, decision-making, so many other things. However, I stand by kind of Rob's conception that what marks smartness is this concept of scale and the fact that you think in networks. Like, it's not one of us makes the decision. This starts with like people in neoliberal thinking, like Friedrich Hayek. It's a market is the only one capable of making a good decision. Each of us individually are deeply subjective. We don't know the world. We don't know everything. We are irrational. We have emotions. We have bad data, lots of things, fake news. Only markets can coordinate our decisions at scale. And today, only large-scale networked computational infrastructures can coordinate, right? Our likes, our social dislikes, even if they're fake, they coordinate what we think or want to be is true. But this happens at scale, right? It does not happen individually. And I think that question of that extra human or that networked intelligence is the fundamental issue in smartness. How do you allocate responsibility in network systems of decision making? How do you create authority? Who gets power? Who's controlling it? And we also know that these systems have a tendency towards oligarchy and to structural injustice, that certain people are actually controlling them far more than the rest of us. So there's a question also here that we haven't really talked about, which is the ideology of smartness versus the practice of smartness. Smartness is also an ideology. Systems, markets really don't make the best decision for everyone, but the ideology of the free market says they do. And social networks and do not just show everyone what they like, right? There are biases, there are injustice, and there are certain structural powers. Only certain organizations can have enough computers, enough networks, enough users to actually be able to create those supposed intelligences, right? AI is an infrastructural project at massive scale. You cannot get a large language model without a vast amount of data and a huge infrastructure that most of us do not personally have, right? So we know that these ideas, so I want to classify that throughout this book, we are both interested in the specific practices, but we're also interested in the ideology. It's not really a mandate, it's an ideological mandate. Smartness is an ideology of how to manage environments, people, societies. And that's what we kind of want to get at, but we also want to say, that's the logic where inside it comes with a lot of technology, and there are maybe beneficial elements, maybe they're not, and that's part of this debate. Is smartness better or worse than a term like artificial intelligence? Is it better or worse than other languages that might denote similar phenomena? We argue that it is, that there's both extreme negatives to it. It's oligarchical, violent, racist, sexist, etc., colonial, but it's also has these other possibilities because it's fundamentally rethought the human in relationship to both the human and both the mechanical and the natural world.
Thank you. Audrey, is there anything you want to add to Suming's question or any of the responses?
I think maybe we can move on to the next question.
Okay, super. I thought linking into what Orit was saying just now, we could go to Jumana's question, which is, would a utopian smart city really promote human flourishing given the control involved and therefore the lack of stimulus promoting growth? So, Audrey, as you kind of didn't chip in on the last question, do you want to have a first stab at Jumana's question, or would you prefer me to pass it on?
Well, maybe ask Rob first, and then I'll chime in.
Okay,
Well-
Rob, back to you.
I mean, yeah, so I mean, I think my first response is just to say that a utopian smart city is, for us, at least I'll say this provocatively, a contradiction in terms, that you don't have utopian smart cities, because utopia, refers really to some sort of final form, and the whole idea of the smart city is that it will perpetually be adapting to new changes. Now, the interesting part of that is it means that critique, especially of the sort that humanities traditionally performs, is totally part of smartness, right? So if someone were to point out in a smart city, look, there's too much control here, presumably, or at least in principle, the smart city would recognize, if enough people thought that way, it would adjust those parameters, right? So the idea, so that critique is not necessarily something that smartness is opposed to. It functions by critique. It learns. That's the idea. It means that there's no end to, there's no utopian final form, but it also, it's one of those things where it's one, I think we felt ourselves challenged in what position do we want to take as humanities scholars on this phenomena, because traditionally humanities scholars can take the position of critique, as being outside and showing the limits. But for a protocol that operates by critique, both self-critique and external critique, then one has to think a bit about, like, well, what exactly, what kind of critique will not be simply co-opted as actually just the operation of the system itself? Because and I don't mean co-opted in the sense that it's tamed. I mean, smartness is, because it's oriented towards learning, demands critique. It itself demands critique. I mean, I don't mean like that it is one of the operations of smartness. So yeah, I'll leave my answer at that.
I also want to add one thing, just looking at the chats, which actually engaged with really specific case studies. I think this kind of question needs to be situated historically, specifically, geographically. There are many, many smart city projects. People mentioned Toronto and Sidewalk Labs failure with the development there. But one could talk about Hudson Yards, one could talk about Singapore, one could talk about Dubai. There's a million different smart cities. And now we're talking about other questions of diversity in organization and the people who are involved in the political process. Like these things are not autonomous. They're located, and again, to just a famous feminist adage, like situated, contested, contingent. Everything is whether a smart city has potential to be more egalitarian, just, diverse, all sorts of nice adjectives, has a lot to do with its situated context, who's funding it, who's making it, who's got agency within it, and what organizations and institutions are involved, who's developing. So just to kind of ground it a little.
May I quickly add that, I mean, something I wanted to discuss, but we didn't have time, was the sense of temporality, as you mentioned in your book, and also the problem with the future. First of all, smartness, as it seems to be emerging, it seems to be incredibly narrowly defined, if it's smart or intelligent at all. And is that really sufficient for a city? Does a city perhaps need a sense of purpose and a horizon of expectation, and more than just, basically some kind of a form of self-reinforcing, self-perpetuating form? And, you know, that would be my critique and my concern, very briefly.
I think the real question is the economies and the values being inculcated into the technology. Again, this has to be very, situated, because there's a lot of ambition and desire, for example, in some of the smart cities, Hangzhou or Singapore, whether they're linked to now they're also hyper consumerist, extreme, certain types of extreme. They're also major, financial centers, technical centers, other things, as well as autocratic sites of governance. Whether the expansionary use of smartness to engage so many systems, from energy to water to everything else, like, is it, I think we have to talk about it not only as actually defining, but also the ill definition of smartness, but it's kind of what economies are actually being articulated through that language, like what economies are being made possible, where is value being produced, how, and values, of course, can be understood as in other ways. How are we producing meaning? On one hand, I'd say yes, there's this kind of traditional argument around like real limitation of imaginaries around what autonomy, agency, decision-making, reason are through these languages, which obviously are necessary in order to make them commensurate with the computer. There's also vast levels of ambition around this term in many, many contexts that I think we need to unpack. I don't know if that helped.
Maybe we have time for one last question.
Yeah, I think we'll go to about 5 past, because we started at about 5 past. So I thought I'd finish with Dean's question. It's quite broad. It's kind of pointing out, which you've done in various ways in the conversation, that AI or big data works from a particular logical or algorithmic model of, or models of knowledge. And Dean's asking, what about bodily or embodied knowledge? How do these realities or concepts fit into this overarching of smartness? What becomes of intuition, bodily intelligence, and I suppose what you might call the slightly more nebulous aspects of knowledge, which nonetheless have typically been part of the ways we think about constructing societies, urban spaces, and so on. Rob, do you want to have a little dabble at that one?
Yeah, I mean, I think there's sort of this, there are two directions, or two. I would come at that question with two directions. One is to say that, and again, Nicholas Negroponte's smart or soft architecture may be a good way of thinking about this, but the aspiration would be to make digitally available as much embodied knowledge as possible. And it's certainly possible to think, okay, well, there's limits when one can't go past, one can't generate digital equivalents of certain kinds of embodied knowledge, and that's just a challenge for then software engineers to try to figure out how they can do it. So one would be to say, yes, exactly. Again, think of Negroponte. He wants to generate data off people who are just living in a city already, and so all of those kinds of implicit bodily knowledges should become digitally linked as much as possible. That's one direction I would come from. The other direction is to say that what we seem to be seeing at present, it could be that within 10 years, this what I'm saying will seem naive, but that of course artificial intelligence and learning algorithms operate by algorithms, but yet when engineers try to explain how a particular algorithm came up with a specific result, they often at this point are not able to really do it. And we might think of this as like, I mean, a sort of embodied knowledge, or at least an implicit knowledge, or we can't make it very explicit, another way of putting it, on the part of the algorithms, so that it's almost that in creating learning algorithms, we create a certain grays or blacks area of indiscernibility for ourselves in figuring out what the heck is actually going on in these algorithms, which is very much like the embodied knowledge that we have. So I would say that both there's an attempt to turn our embodied knowledge into digital equivalents, and the simultaneous creation of kind of like an implicit knowledge within these computer programs themselves. I don't know if Orit agrees with that part of it, but
Yeah, absolutely. I think it's really important, like for me, like just even thinking about the history helps you think about that, because the neuron was, is seen as a mode of being able to make decision in a kind of embodied way. And the sense was that the architecture mattered, that it wasn't just everything in logic, that actually how these nets were set up would actually matter in terms of how they did calculations. And I think Rob is right. There's like really interesting things happening here between the way we're trying to turn our bodies into data and simultaneously the kind of embodification, I guess, and unknowability being a certain to machine architectures.